So in section 1.3, we're talking about a specific type of function called the linear function, meaning line. So objective 1, we're going to start talking about the slope, but before we get there, we have to talk about the function. So the linear function is just, if you can write it in mx plus b form, where m's your slope and b's your y-intercept. So this first figure shows that. Notice that we have our slope here of 1/5 and our y-intercept of 2, and we're crossing at 0, 2. Then up here, the constant function is just a horizontal line if your slope is 0. There's no rise, there's no run. So we're just going straight across. So I kind of drew it, it's kind of ugly. But f of x equals b, where no matter what our x is, our y value is always b, and we're crossing at 0, b. Last but not least is the identity function, which just means yourself, meaning whatever x value you plug in, yourself, you pop out. You are the y. So if you notice here, every value of x has the same value of y. So whether it's a positive 1 or a negative 3, the y is the equivalent to what you plug in. So let's start talking about slope. Slope has a variety of different ways we can use it. So we're going to use it pretty basic, like here's a line, what's the slope? But then we're going to have applications of average rate of change and so forth, where we're going to be asked to find those, but the slope formula is all we're using. Rise over run is how I remember it. So that I remember it's just how far my y values apart compared to how far my x values are apart. And it doesn't matter which one you use as long as your points correspond to each other. So do not pick the first y and then the second x, or vice versa. Okay? So one thing before we flip the page over, I just want to make sure we can use this formula. So let's figure out, using the points right here in figure 1, what its slope would be. So figure 1. So I'm going to put m equals y2 minus y1 over x2 minus x1. All right? So looking at lines, lines are indefinite, meaning there's an infinite amount of points you can choose. I say choose the ones that are labeled. Those are usually the easy ones. So say 0, 2 is our x1, y1, and 5, 3 is our x2, y2. I'm going to pick my second y first. So 3 minus my first y of 2. Oh, my 2 is kind of creepy there. All right, so 3 minus 2. But then since I picked the 3 first, the x value that goes with it, 5, is going to be the first x down here, minus whatever x value went with our 2. But if you go back up here, our x value was 0. Okay? So you get 3 minus 2, or 1 on top, 5 minus 0, 5, 1/5. And notice, guys, that matches the slope m that they said went with that line, 1/5. Also keep in mind, you can also see it visually. How far do we go up? We go up 1 and over how many? 5, right? Oops, here we go. So we went rise of 1 over 5, rise over run, 1/5. Let's do the same thing with figure 2. For figure 2, I'm going to do m equals y2 minus y1 over x2 minus x1. And again, I'm just going to pick 4, 4 as my x2 and y2, and 1, 1 as my x1 and y1. So I'm going to pick my first y, which is 4, minus my second y, which is 1, over my second, or however we say it, my x value that went with the 4 was 4, and my x value that went with my 1 is 1. So this ends up being 3 over 3, which reduces to, can I just circle my page number? Look, that's the answer. Oh, perfect. Okay. So my slope is 1. But if you go back and look at the formula, your slope is always in front of your x value. So what's technically in front of our x value, guys? 1. A 1. So there he is. All right. So that's just kind of to make sure we feel comfortable. A couple notes before we turn the page. If you have a positive slope, that means you're increasing, right? So as you go from left to right, your line's going to go upwards. If you have a negative slope, you're decreasing, so you're going to go down as you move from left to right. Okay, so here are two special cases. If you have a horizontal line, which we kind of talked about just on that front page, guys, it's called the constant function. It has no rise, right? So how much did you go up from point to point? You went up nothing. So its slope is technically 0. So horizontal lines have a slope of 0. So kind of keep that in mind. So horizontal line, slope is 0. And notice that, if we picked any 2 points on this graph, the y values would be the same, right? Even if this was 2, 2, and this was 4, 2, You would do that first thing, 2 minus 2, and you get 0. Yes, ma'am?
So wouldn't that be constant?
That is our constant. This is exactly what that is. So this is called the constant function. And then on the other side, we actually have the exact opposite. Whenever you have a vertical graph, notice if you use the formula, and I like how they show it with generic, but no matter what, your x values are going to match. So on the bottom you have 0, and what do we know about dividing by 0? It should not happen. So it's called undefined, and how I explain it is that it's so steep, we can't even give it a value, right? So vertical lines have an undefined slope. All right, so those are 2 easy ones where you don't, I mean, worst case scenario, you don't remember, so you can use the formula for them to figure out the slope, but you shouldn't have to. You should look at a horizontal line like rise over run, I'm not going up, it's 0, versus a vertical, oh my gosh, I'm so steep, I can't even give it a value, so it's undefined. All right, so let's jump at some examples of where we would see these in real life. So it says the grade of a road is a number expressed as a percent that tells you how steep a road is on a hill or mountain. So like a 4% grade means the road rises 4 feet for every horizontal distance. So again, that's that whole idea of rise over run, okay? So the rises, oopsie, my pencil's not gonna work right now, is it? It rises for the horizontal. So this is the rise over run, all right? So this is I think, the picture doesn't seem to go with it. I guess it's a mountaintop, guys, that's going down. And are they parachuting onto the mountain? Is that what's going on? I'm not sure what's going on, okay? But let's go ahead and read our first example. It says, construction laws regarding access ramps for the disabled state that every vertical rise of 1 foot requires a horizontal run of 12 feet. My husband works for IDOT as a civil engineer, and ADA compliance is making its way through the nation. Like, everything has to be compliant versus, like, not only do they have to have that, but they have to have those bumpy things that look like Legos, right? All that kind of stuff. The curb has to be so tall or so low and so forth, okay? So notice again, though, vertical rise, so that's the top number, over horizontal run, that's the bottom, okay? So our grade, guys, is just going to be 1 foot to 12 foot. And if it was just slope, you know, the feet would cross out, and you would say the slope is just 1/12. But since it has this application of grade where it's as a percent, what we're going to do is we're going to divide these and then multiply by 100, okay? So what is 1 divided by 12? No, 12 divided by 1 is 12, right? So 1 divided by 12, we're smaller than that. What do you guys get?
0.083.
All right. So the 3 is repeating, okay? So if we were to make this a percent, we're just going to times it by 100, and let's just round to the nearest 10th percent and say 8.3%. So in order for a ramp to be ADA compliant, that ramp has to have an 8.3% grade, meaning 1 foot to the 12-foot run. So it's just kind of an actual real-life example of where we would use slope, all right? Another real-life example of where we could use slope is rate of change. So if you're comparing one value at one point in time to another value, you can find the slope, and that tells you how quickly things are changing, okay? And that's what's happening at the top of page 3. So it says, bless you, slope can also be considered as an average rate of change. So to find the average rate of change between any 2 data points in a graph, we would just determine the slope, but sometimes coming up with the points is harder than like a normal, like, oh, here are 2 points, find the slope. So what we're going to do is we're going to look at this graph. This graph represents how much of travelings are booked online, okay? So if you look way back in 99, 6% of all traveling was booked, 6% of it was online. Jump to 2007, that's gone up to 55%. So the question is, how quickly is that growing? What is the average rate of change? So in general, this is not a perfect line, but we kind of would estimate it to be a perfect line. So our question is, what is the slope? All right? So before we do it, we have to come up with 2 ordered pairs. And realize your ordered pairs are exactly like they are in the Cartesian coordinates. What are your x values, the years? What are your y values, the percents? Okay? So the first point, so we'll say points, The first point is 1999, and what was its y value? 6%. So that's going to be our first ordered pair that we're going to deal with. When we're actually doing the math, we won't worry about year or percent. We'll just do it with the numbers. What's the last point we can use, guys? What year do we have marked? You got it. And what is the percentage that goes with it? And there are your 2 points. Okay? And at that point, we would just use our slope rise over run. y2 minus y1 over x2 minus x1. And I write it, the more I write it, just so I remember it. So this is going to be y2 minus y1 over x2 minus x1. So I'm going to pick this y first, and again, don't worry about the units. So we'll do 55 minus 6. And since I chose 55 first here, I'm going to choose its corresponding x value, 2007, first here. Minus whatever one went with 6, it's 1999. And I think this really, really shows you the whole idea of change, rise over run, like how much growth was there, aka the rise, in the year change, right? How many years passed? So we're going to have this average idea of, okay, 8 years passed, but how much did it grow? So we can get this whole average idea. What's 55 minus 6? Is that 49? Over 8. So I would just throw that in my calculator, and you get 125? Okay. And this one's a little bit different because rate of change, you usually do have a unit, okay? So you go back and say, okay, what would my unit be? Well, what was the top numbers representing the 55 and 6? What was their unit? Percents. Are you okay with that? Percent per, right? And that per is just this division bar, right? So what was 2007 and 1999? They were the years. So all this means, guys, is in general, on average, the bookings online increased 6.125% each year, okay? Is it perfectly that? No, we have some highs and we have some lows, right? But if we could say it was, in general, a nice linear function, that would be the slope. All right, so the last thing is, now that you kind of know what a linear function is, and now that you know its part, the slope, and the y-intercept, if I gave you a function, could you tell me what the slope is and what the y-intercept is and so forth, all right? So let's look at this. It says the linear function f given by mx plus b is called slope-intercept form. The constant m is the slope, which we kind of talked about on the front page, and that b is the y-intercept. So on this problem, go ahead and write this down. So we have the function f of x equals 2/3 x plus 4. What is the slope? What is the y-intercept? Well, whenever it's in this form, we can just pull it straight off of there, okay? Your slope, m, is always going to be that value in front of your variable, okay? So they could be mean, and they could have this written 4 plus 2/3 x. It doesn't matter. You're looking at that variable, and wherever the variable is, that number in front is your slope. So in this case, what is our slope? 2/3. And then what is our y-intercept?
4.
It's always a constant. I'm not 100% sure, but I'm 95% sure since it's an intercept, it is a point. So I think they usually want it in ordered pair form. So 0, 4 is how we would write it. If they had b equals, guys, they're stating I just want the b. So the b would just be 4. But if they want it as an ordered pair, it's 0, 4. Is that all right, guys? And I think that's it.